Kuzzangpo and welcome to Bhutan e-learning project. I am Ganapati Paudel from Kabisa Central School, Punakha. This lesson is a science lesson for Key Stage 3, Class 7 and 8, and the topic of the lesson is pressure. So we will start with our lesson. I hope you are with me. Let's first look at the objectives of the lesson. At the end of the lesson, what are we going to learn? So let's look at the objectives, lesson objectives. First one, explain pressure. Means at the end of the lesson, we should be able to explain pressure. Second, construct relationship between force, pressure and area. So we need to find or we need to construct relationship between force, pressure and area. Third, we should be able to calculate force, pressure and area. And lastly, explain the application of pressure in our daily lives. So these are the objectives that we are expected to learn as we complete this lesson. Let's go on. Firstly, let's look at what is pressure. It's very important to understand what is pressure. Okay, you might have got some idea when we say what is pressure. So let's look at pressure is the amount of force acting perpendicular on a unit surface area. How much of force is acting on a unit surface area, that is called the pressure. Okay, so you can look at this. It's the force acting on a unit area. So you can see there force is applied from above and then you have a circle surface area, unit surface area. So how much of force is acting on that surface area, that is called pressure. Okay, to understand this little better, let's look at this. If we place any object on the table which is parallel to the surface of the earth, table is parallel to the surface of the earth, so the force exerted by it will be equal to its weight. Remember that. So if you are placing any objects parallel to the surface of the earth, then the force exerted by it will be equal to its weight. Okay. Another one, when we stand on the earth's surface, the force exerted by us will be equal to our weight. So we need to understand this because later on in many cases, so you will be given the weight and sometimes we need to put that weight as force. I hope you are with me. Is it clear to everybody? Yes. Okay, let's explore the relationship between force, area and pressure. So we know what is pressure. Now let's go and see some more about what is the relationship between force, area and pressure. To learn about this, we have some investigations. So we have investigation 1. Okay, let's go. Look at this. We have a plywood there which is 0.5 mm thickness, and then we have a brick which is 1 kg. Now when we place the brick on the plywood, the brick will exert some pressure. You will see, if you agree with me, that when we put the brick on the plywood bends a bit. So what would happen now? What would happen if I place similar brick on similar plywood? Let's look at this. Okay, B. Is there any difference that you observe here? So thickness of the plywood is same, the mass of the brick is same. So let's look at which plywood bends more and why. This is the question. Since everything is same there, area of contact is also same, the force is also same, so A and B bend equally due to equal force and area. So when you talk about area, you can see here the area of contact of the brick with the plywood in both the case is same. The base, you can look at the base. And then the force is also same because both the bricks are of equal mass. So, if force is equal and the area is equal, then you can see that okay, the bending of the plywood is also equal. Okay, let us go on with the next investigation, investigation 2. Okay, in investigation 2, you can observe, okay, this is the plywood with a brick on it, and the thickness of the plywood is same. So, here I am going to place the bricks little bit in a different way. Okay, please observe. Okay. So, here in C we have placed 1 kg or a brick on 0.5 mm plywood, and in the diagram D we have placed 1 kg brick on the plywood that is of thickness 0.5 mm. The thickness of the plywood is same, the mass of the brick is same, but what is different there? Which plywood bends more? Explain. In this case, D bends more than C, because if you look at D, although the force is same, but what is different is the area which comes in contact with the plywood is different. Area is smaller in D, whereas it is the contact area is bigger in C. We will further look at another investigation. Please remember this investigation, and later on you need to find out what really happens, what is the relationship between force, pressure and area. Okay, let us look at the third investigation. You can see the same 1 kg brick is placed on the 0.5 mm plywood there, and then what would happen if I placed more bricks? In figure E we have placed 1 brick, and figure F we have placed 3 bricks. Okay. Which one bends more? You need to justify. Since we have more bricks there, the force acting on the plywood is more, and plywood F bends more than E, since the force exerted by 3 bricks on F is more than the force exerted by a single brick of the same mass on plywood E. The area of contact in both the cases is same. But then what is different there? Force is different. So, please take a note what happens when force increases or what happens when force decreases. Is that clear to everybody? Are you with me? Okay. Now, having done these 3 investigations, we are now going to conclude the relationship between force, area and pressure. In the first investigation, force was equal, surface area was equal, and the bending of the plywood was also equal. In the second case, we have seen that the force was equal, but surface area was different, and there was difference in the bending of the plywood. Okay. And then third one, we have seen that surface area was equal, but force was different. Okay. So, with that, what conclusion do we come to? Let us see. Okay. Number 1, if surface area in contact remains the same, if surface area is same, then pressure will increase with increase in force, and pressure will decrease with the decrease in force. So, this is the finding that we have got. This is the conclusion that we have derived from those 3 investigations. Hence, pressure is directly proportional to force, area remaining constant. So, if area is constant, pressure is directly proportional to force, which simply means that when force increases, pressure also increases. When force decreases, pressure also decreases. Okay, second one, if force remains same, pressure increases with decrease in surface area and vice versa. Hence, pressure is inversely proportional to area, force remaining constant. So, these are the 2 findings that we have got. We already know that pressure is force exerted per unit area. Force exerted per unit area. So, if you put it symbolically, here we have P equal to F divided by A. Pressure equal to force divided by area. Okay. Now, let us talk about unit of pressure. So, we can find the unit of pressure from the unit of force and unit of area. So, unit of force, as you know, is Newton, which is denoted by N, capital N, and unit of area is meter square. Therefore, the unit of pressure is Newton per meter square, N/m square, which is also called Pascal. And then I have given the relationship here. You can see 1 Newton per meter square is equal to 1 Pascal. Pascal is the name of the scientist here, and this unit is derived from his name. I hope this is clear. Now, having derived the relationship, having looked at the units, we are going to do some numerical questions. Okay. Please be ready with your notebook, pen, and then we are going to do it. Okay, let us look at this question. What will be the pressure exerted by a force of 100 Newton on a surface area of 10 meter square? This is the question. What will be the pressure exerted by a force of 100 Newton on a surface area of 10 meter square? So, when we get this type of questions, firstly we need to look at what is given in the question. What information is given in the question, we need to look at that, and then we need to note it down. Okay. So, let us look at force is given. How much is the force? 100 Newton. Then what is given? Area is given, which is 10 meter square. Okay. Now, what are we supposed to find? We are supposed to find pressure. So, pressure equal to question mark. Now, you can write down the expression, you can write down the formula. Pressure is equal to force over area. Okay. What is force? 100 Newton, and divided by what is area? 10 meter square. So, we get the answer here, 10 Newton per meter square. That is the pressure. That is the pressure, or 10 Pascal. It is very simple, right? But you can see here it is very direct. We use this formula directly, P equal to F over A. But what if you are asked to find F or A instead of P? So, to get that idea, we are going to do one more question. Please look at the question. So, you are asked to find the area, not pressure. Remember that. Okay. As we have done before, let us take down, let us note down the information given in the question. So, force is weight. So, we have already seen that if a person is sitting on the floor or standing, the weight will be equal to its force. Okay. So, force here is 1000 Newton, force is 1000 Newton, and pressure is given 100,000 Newton per meter square. Okay. What are we asked to find? Area. Area is equal to question mark. Let us bring the expression or formula, P equal to F over A. We already know this, P is the subject of the formula, and since we are asked to find A, now we need to make A as the subject of the formula. So, P times A equal to F, okay, A equal to F divided by P. Are you getting? Are you with me? Okay, good. Now, we just substitute it. Force is 1000 divided by pressure is 100,000, and then the units also can be divided, Newton divided by Newton per meter square. So, that will give 1 over 100 meter square, and then finally, if you want to change it into decimal, it is 0.01 meter square. So, this is the answer. Is that clear to everybody? Okay. Now, let us move on with our lesson, application of pressure in our daily life. Let us look at, okay, number 1, why do you think school bags have broad straps or belts? Look at this school bag. I think all of you carry school bags, and then the belts or straps that are used in the bags are not narrow, they are broad. Why do you think so? Okay, broader straps provide more surface area in contact with our shoulder here. So we usually carry school bags on our shoulder, and then if you have narrow straps, then it will exert more pressure. If you have broader straps, it will exert less pressure. So we want less pressure on our shoulder. Okay, let's look at next one. Why are nails pointed? Okay, you see, nails are pointed to provide less surface area and can easily be drawn into the surface with less amount of applied force. If the nails are pointed, surface area will be less, and when the surface area is less, the pressure will increase. So we can, with little bit of force, we can nail them easily into the wooden block. So that's the reason why nails are pointed. Let's look at next one. Why are drawing pins easier to use? You might have seen drawing pins like this. What part of the body do you use when you are using drawing pins? Usually our thumb. Head of drawing pin has a large surface area so that it can be pinned easily without exerting much pressure on our thumb. So since we use thumb, if the head is narrow, then it will exert more pressure, then we cannot pin it easily. Okay, next one. Why do you think that camels can walk easily on the sand? Look at the camel feet. Okay, you can see the camels walking on the sand. Why do you think so? Okay, did you get the answer? Did you think? Let's see. Camels have broad hooves that apply less pressure on sand. Broad hooves which will apply less pressure on sand, hence they can walk easily. Their hooves do not go inside, deep inside the sand, because the surface area is broader. Yeah, let's move on. Sharp knife cuts better than blunt one. Give reasons. So when you work in the kitchen, we always look for sharp knives, because they cut better than the blunt ones. So what could be the reason? You can see there in the first picture. The first this knife is sharp, another one is blunt. Okay, you can see here blunt knife not able to cut easily, and the last one, is it cutting easily? Yeah, sharp knife. So sharp knife cuts better than the blunt one. Okay, why? I hope you have come up with the answer. Since the surface area of a sharp knife is small, the pressure applied will be greater. So sharper the knife, greater will be the pressure, and then it will be easier to cut. Now I have some lesson quiz. First one, pressure is defined as dash over a given area. Did you get the answer? Yeah, it's very easy, we have already learned. So pressure is defined as the force over a given area. Okay. Let's look at next one. What is the standard unit of measurement of pressure? Newton per meter square or Pascal? Very good. So this is what we have already learned. Okay. Now what pressure will be exerted by a 10 Newton box that has equal sides of 1 meter? So what pressure will be exerted by 10 Newton box? Force is 10 Newton and the sides are 1 meter. 1 meter means the area will be 1 meter square. So what will be the pressure? So we know that P equal to F over A, force over area. Okay, let's check whether you have your answer is correct or not. So 10 Newton per meter square or 10 Pascal. So force is 10 Newton and area is 1 meter square. So 10 over 1 is 10 Newton per meter square. Question number 4, please read the question carefully. A red cube with sides of 3 meters and a blue cube with sides of 2 meters are on the table. they both weigh the same, which means force is same. Which cube exerts more pressure on the table and why? So, what could be the answer? The answer is blue cube. Blue cube exerts more pressure because blue cube has less surface area, but the force is same in both the cases. And then why? Blue cube has less surface area which comes in contact with the table as compared to red cube. That is why it exerts more pressure. Now, I have some questions for you to explore at home. At home you can take your time and then try to solve these questions. I hope you will enjoy doing this. Let us look at question number 1. Okay. This is a worksheet for you. What you need to do is draw and describe an object that is designed to decrease pressure. On the other side, draw and describe an object that is designed to increase pressure. Let us go to the next question. Question 2. Observe the following figure and answer the question. Okay, look at the figure. So, we have the figure there. There are 4 blocks A, B, C, D, and then you can see the mass same 100 kg, all of them. Okay, and you can easily make out what is different there. Okay. Arrange the above blocks A, B, C, D in terms of pressure exerted by them on the plank from least to greatest, and you give reasons. That is all for today. Thank you, and I will see you again. Thank you.